we'll see what we can get through today. It's only like 10 slides worth. And then you are going to have test review Wednesday, Thursday this week, and then test coming up Friday, Monday, over all the hypothesis testing stuff. Yeah? Yes, okay, so let's just get started. We'll see what we can get through. So this has a little bit of 6.3 in it. We saw this information at the top here in, I think it was like 7.1. I mentioned it. We talked about a little bit with proportions. We're going to show up in some of the hypotheses that we saw. We were going to use a P. Just a P is the population proportion. It's essentially a percentage. P hat, which has the little kind of like carrot thing at the top of it, is a sample proportion. So if it's just a P, it's population. If it's a hat, it's a sample. And what that little formula is, X over N, it just allows us to calculate a percentage. X is the number of successes, and N is the total number, as usual, in our sample. You need to know that Q hat is the complement of P hat. So for example, if P hat was 0.4, Q hat would be 0.6, one minus the other, okay? So first thing at the bottom, super quick, it's kind of what you guys did in Algebra 1, we're just giving it a new name now. It says finding a point estimate for P. It says in a survey of 1,550 U.S. adults, 1,054 said they use the social media website Facebook. Find a point estimate for the population proportion of U.S. adults who use Facebook. So if we're asking for a proportion point estimate, it's the sample proportion, or P hat is what you're calculating. The formula is X over N. X is the number of successes, or in this survey, the number of people that said yes, and then N is the total number surveyed. So in this example, it would be 1,054 said they do use Facebook, and 1,550 total were surveyed. You divide it, turn it into a decimal. And then you want to give it at least probably 3 decimal places, because it could make a big difference in some of the hypothesis testing if you cut this guy off a little too much. And this one actually ends up being exactly 0.68. The other thing you could do then is find Q hat once you have P hat, which is the complement. 1 minus 0.68 is going to give you 0.32. Okay. So out of the people surveyed, 32% said they did not use Facebook, or gave some other type of answer other than yes, I do. Questions there? Quick and easy. Okay. So when we do margins of error, confidence intervals, hypothesis testing, any of those things with proportions, normally we've talked about the sample size has to be bigger than 30, or the population is normally distributed. That is not the case with proportions. To make sure that you can do the testing or the confidence intervals, this is what you want to check. Okay, so this is kind of like step 1 in every problem that we do. N times P hat needs to be greater than or equal to 5, and N times Q hat is greater than or equal to 5. That's checking that we can use a normal distribution to represent this information. Okay, so I'm going to go back to the previous slide. We're just essentially making sure that our data is big enough and our percentages are large enough. So if I do N times P hat, it would be 1,550 times 0.68. N times Q hat, 1,550 times 0.32. And as long as these numbers are bigger than 5, we can represent this with a normal distribution, which means we can do all of the testing we want to do in a minute here. Okay, first one gives me 1,054. Those are the people that said yes. We kind of knew that one already. That's 68% of the total. And then 1,550 times 0.32 gives me 496. Both of those greater than or equal to 5. So check. That's what we're looking for. Okay. All right. Any questions so far? No. All right. So confidence intervals. Confidence intervals are going to work the same way. We are estimating P, which here is the population proportion. Okay. And to do that, we're going to take P hat, which is our sample statistic, and add and subtract a margin of error to it. And that's going to give us a confidence interval. Margin of error formula is slightly different now. Okay, so you can see that we are using z's when we do this, a critical value of z that we'll get off of our chart. And then we are multiplying that. We don't really have like standard deviations here. We instead are going to do the square root of the numerator p hat times q hat, which we just talked about how to calculate, divide by the square root of n. And then whatever that margin of error is, we're going to add and subtract it to p hat to get a confidence interval. Okay. So you will need your chart for this, the Z chart, if you don't have it out already. All right, so the figure below is from a survey of 800 U.S. adults ages 18 to 29. Construct a 99% confidence interval for the population proportion of 18 to 29-year-olds who got their news on television. Okay, so we are only concerned from this chart with people who got their news from television. Okay, so first thing I'm going to look at is what's N, P hat, and Q hat. And then I'm going to make sure that both of those are greater than or equal to 5 when I multiply them together, and I can actually do my confidence interval. All right, so what's N? 800. P hat is the number of successes. Now here we don't have to calculate it because we were told the number of people that watch TV are 27%. So the number of people that don't watch TV are what percent? Or well, get their news from TV. What percent? 1 minus complement 0.73. Okay, N times P hat and N times Q hat as a check before we go any further. So 800 times 0.27, that's going to be the number of people that said yes to getting their news on TV. 800 times 0.73, get it some other way. 800 times 0.27 gives me 216. 800 times 0.73 gives me 584. So good. Both greater than or equal to 5. Check. All right, calculate the margin of error, and we're going to need a z-score to do that. All right, so on your chart, mine's pink. Remember, we have critical values at the bottom. That's what your yours, I think, was at the top of your paper. Critical values is what we're looking for. It says level of confidence. So level of confidence here is a 99% level of confidence. So you're looking for a 0.99, and you should see 2.575 is the critical value of Z that we're using. Okay. So margin of error formula is critical value of Z times the square root of P hat, Q hat over N. All right, so 2.575, I'm just going to fill it in. 0.27, 0.73 over 800. I'm just going to type that in our calculator. Graphing calculator makes this a little bit easier. 2.575 times the square root, set up my fraction under my square root. And I'm going to give it 4 decimal places because what we're getting here is an error on a percentage. So you can think of this as 4.04% instead of just a flat 4%. So that's our margin of error. So now our confidence interval, 99% confidence interval, we do P hat plus and minus E. When we were doing this before with the means, we did the sample mean plus and minus E. So it's always a sample statistic plus and minus E. P hat was 0.27 plus and minus 0.0404. So 27% plus and minus about 4%. So I'm going to get a confidence interval of 0.2296 and 0.3104, or again, you can write it with percentages. Like that. So we're estimating that the population of 18 to 29-year-olds, between about 23% and 31% of them are going to get their news from television with 99% confidence. So remember, if you were going to interpret that, we'd say we can be 99% confident, or there's a 99% probability that 18 to 29-year-olds get their news on television between 23 and 31% of them. Okay, any questions on any part of that? Okay, that is pretty much the 6.3 stuff that we did not do back in chapter 6. So what we're going to do now is the stuff that comes from section 7.4, if you're looking in your book. We're going to take those things from our confidence intervals and our proportions and do a z-test with a hypothesis test. So a lot of this is going to look the same as what you guys are used to. So we're going to check that at the beginning. That's what we just practiced. We're going to write hypothesis, a null, and an alternative, same as before. Level of significance, most time that's going to be given to us. Critical value is going to be a z-value. Rejection region from the critical value will determine if it's left tail, right tail, or two tail. So we'll put the minus and the plus, or the plus or minus on it. To calculate the z-value, circle this. This is going to be the test statistic that we are going to compare to see if it's in our rejection region or not. So this is a new formula that we calculate a z-score with proportions. Okay, so we'll have our z-score off a chart. We're going to calculate that z-score, which you can see the margin of error in the bottom there, the PQ over N piece. We always divided by a margin of error before when we did that z-score. And then, just like before, the last two steps, if it's in the rejection region, we'll reject. If it's not in the rejection region, we don't reject. Okay. Okay, good? Great. Okay. All right, so let's do one. A researcher claims that less than 45% of U.S. adults use passwords that are less secure because complicated ones are too hard to remember. In a random sample of 100 adults, 41% say that they use passwords that are less secure because complicated ones are too hard to remember. At a level of significance of 0.01, is there enough evidence to support the researcher's claim? Okay, so I'm going to start by finding N, P hat, and Q hat, and then making sure I can do my sampling distribution. What's N? 100. P hat is the sample that said yes to this. What proportion said yes? 41% said they use passwords that are less secure, which means Q hat would be the complement of that, which would be 0.59. Okay, and then this one will be some quick math, checking my N P hat and my N Q hat. So 100 times 0.41, that's going to be 41. And 100 times 0.59, that's going to be 59. So both of those are good. Step one done. Okay. Next, let's write our hypotheses. The null and the alternative. Okay, so what's the claim being made? The claim is that less than 45% of U.S. adults use passwords that are not secure. Okay, so since it says less than, is my claim the null or the alternative? It is the alternative. And we're not using mu here because we're not making a claim about the mean. We're making a claim about the proportion. So we're going to put a lowercase p without the hat on the top of it. That means population, okay? And it's less than 0.45 and that's my claim. So then the null would be that the population proportion, P, is greater than or equal to 0.45. Okay. My level of significance was a 0.01. Okay. Let's find our critical value of Z that goes along with that. And to do that, we need to know if it's a left tail, right tail, or two tail test. If it's less than, and the alternative, is it left tail, right tail, or two tail? It is left tail. Okay, so these are the ones that you guys wrote in on your chart. Okay, so you're going to look for left tail, level of significance, 0.01, and you should see negative 2.33. We can draw the rejection. Yep. If it's 0.03, then we have to calculate it ourselves. So we did a problem like that. I'm trying to remember what section it was. It might have been in like section 7.1. You have to figure out what area is in the tail, and then you have to look for that number. So let's say it was 0.03 and it was a left tail. That means 3% is below in your rejection region. So you would search for 0.03 in here, and that Z value would be your critical value. If it's a right tail or two tail, we just have to adjust, like do the complement or double it, because we have two tails. Okay. All right. Was that the same question? Somebody? Yeah. You always look at the alternative hypothesis. So if it's less than, it's left. If it's greater than, it's right. And if it's not equal to, this one is two tail. Good questions. Okay. So I'm going to draw that rejection region. Negative 2.33. Okay. And now we're going to calculate our Z value for our sample statistic to determine if it's going to be in that region or not, and was reject or not reject. So the formula you had on the previous page was P hat minus P. It's always sample minus population. We did the same thing with our means. We did X bar minus mu. And then the denominator is P Q over N. Okay. So P hat is 0.41 minus P 0.45. My N I have 100. My P I have 0.45. We don't have Q, we have Q hat, which is different. So when we see Q down here, that means the population complement. Okay, so if my Q hat is 0.59 because it's the complement of P hat, I can use P to get Q. If P is 0.45, what's the complement of that? Q. 55.55. Okay, so those are population values you're seeing. The only one that is going to be a sample from that Z-score is that 0.41, that P hat. And we just type that whole thing in our calculator. You can do it in two separate pieces if you want. This one's going to be a negative 0.04 on top. I know that one at least. So let's see, 0.45 times 0.55 divided by 100 and take the square root of that. I'm going to get about 0.0497, give it a few decimal places, and divide it, negative 0.804. That's my Z-score. Okay, so is it in the rejection region? Nope. Okay, so do we reject or not reject? Do not reject. Okay, so then we summarize same as before. So if we do not reject, we say there is not enough evidence to, and then we look at where my claim is now. So do we use the word reject or support here? If my claim is the alternative. Support. There is not enough evidence to support the claim made by the researcher that less than 45% of US adults use passwords that are less secure because complicated ones are too hard to remember. Okay?
So if you don't reject it, you always put there is not enough evidence.
Correct. Mm-hmm.
No matter what, like.
No matter what. Not reject, not enough evidence. Reject is enough evidence. And then the only other thing you guys do like the drop down menus in Math Excel. You can see kind of those are the two things we change out every time. If the claim is the alternative, it's support. If the claim is the null, it's reject. All right, good. Questions? Okay, let's see what else we got on here. You know what? We only have 3 more slides. I say we get it done, and then you can have Math Excel workday tomorrow. Sound good? We'll do them together, though. Okay. All right. Researcher claims that 51% of U.S. adults believe incorrectly that antibiotics are effective against viruses. In a random sample of 2202 adults, 1161 say antibiotics are effective against viruses. At a level of significance of 0.1, is there enough evidence to support the researcher's claim? Okay, what's N? How many people were sampled? Okay. P hat, Q hat. Okay, now here they don't tell us the proportion that said yes in the sample. They tell us the number that did. So you have to calculate P hat, which we did that earlier. That's X over N, the people that said or confirmed yes to that question, 1161 in this case, over 2202. All right, 1161 over 2202, and we get 0.5272. I'm going to give it a few decimal places out on these ones, okay? So Q hat, because they're not exact. 1 minus that. 1 minus 0.5272, and I get that. Okay. We do have to check that these values are greater than or equal to 5, which 2202 times about 53%, so 53% of that, about 47% of that, those are definitely going to be greater than or equal to 5. I don't actually care what the number is. As long as it's bigger than 5, I'm good. All right. Hypotheses. Claim that's being made is that 51% of U.S. adults believe incorrectly that antibiotics are effective against viruses. There's no less than, greater than, any statement like that. So this is an equal to, not equal to example. So it's saying that 51% adults believe. So 51%, the proportion equals 51% is my claim. That's my null. Which means the alternative is going to be that it's not 51% of the population. Okay. Since I have P, let's go ahead and get Q because we're going to need that in a minute. If P is 51%, Q for my population is 49%. My level of significance is 0.10. Is this left tail, right tail, or two tail? This is two tail. All right, and this is a common value again on your chart. Looking for a critical value of Z, level of significance 0.1, two-tail test. You should see plus and minus 1.645. And then you can draw that. Two-tail. Negative 1.645, positive 1.645. Question so far? Doing okay? All right, let's calculate Z. We do P hat minus P, And then the margin of error is PQ over N for my population. All right, so P hat 0.5272 minus P 0.51 over 0.51 times 0.49 over 2202 at the bottom. .0172 multiply those together, take the square root, 0.0107 about. And I get 1.615. Okay. And I really didn't round in my calculator until the very end. I was just using previous answers there as much as I could. And you can see why we want to be careful with rounding, why we want to give p hat a few decimal places here. You can get really, really close to your rejection regions. And rounding can definitely make a difference. If I had rounded that p hat value to like a 0.53, it could have made a difference on whether I was rejecting or not rejecting here. Are we rejecting or not rejecting? We are not rejecting. It's close, but we do not reject. So is there or is there not enough evidence? There is not enough evidence to reject the claim that 51% of U.S. adults believe antibiotics are effective against viruses. Okay? Questions there? All right. Last two questions. This one is, I think, a graphing calculator question that's next. I'm pretty sure. Yeah. Okay, so you need your graphing calculator for this. So we just did hypothesis testing with rejection region. Make sure I type this in the calculator right. I made a note to myself how to do this. We have done p-values before with our z-chart, but it's a little difficult when we're doing proportions, so we just pretty much use the calculator. When you see these in Math Excel, this will be a calculator question. We'll just do one of these so I can show you what they look like when you get to it. Oh, that's the wrong one. There we go. Okay, so here they're giving you enough information. They're giving you the claim, they're giving you the level of significance, and they're giving you a couple sample statistics. They're giving you your p hat and your n is equal to 90. Okay, so the value we're looking for, we're going to go back into stat and go over to tests, and we want the one that says 1 proportion z-test in your calculator. So we've done z-test and t-test before. That was just with our basic hypothesis testing. Those are mean testing examples there, but we want the one that's a proportion test. We only have one proportion here. That's why we're choosing this option. Can I make that a little bigger? There we go. Okay. So things we want to put in here first, we want to check p sub 0. P sub 0, it was just like the mu sub 0 that we saw before. That's the value that shows up in our claim. So in our claim here, that's a 0.48. So we're going to put that one in, okay? Our X is the number of people that said yes, and our N is the number of people total that were surveyed. Now here, we know the number of people that were surveyed. The N is 90. Now, oh, that's not a 9. Now what we don't have is X, but here's what we do know. P hat is equal to X over N. So we do have like this quick little calculation we need to make. When they give us P hat and they give us N, it's enough to get X to be able to put that in our calculator. The number of people that said yes, because we know 40% overall said yes to whatever this question is being asked. So to solve for X, I'm going to multiply by 90. And I get 36 is our X value that we're going to put in the calculator. Okay. All right. based on the claim, is the claim a null or an alternative hypothesis? Up here. Is this a null or alternative? Yes, and you know that because it has the statement of equality, which means the alternative would be P less than 0.48. So is it left tail, right tail, or two tail? That's what we need to tell the calculator. This is left tail. Okay, so we're going to select left tail, which is our less than 1, and that's actually already selected for me. And then you can make it whatever color you want. And then we're going to hit calculate. And the p-value is what we care about here. That's what we're looking for. So when we don't use rejection regions, we're looking at the p-value, and we are comparing it to the alpha value, remember. Okay, so here we have p is about 0.064, and we have alpha was 0.08. So less than, greater than, what do we have? It is, P is less than alpha, greater than alpha? Yep, it's less than. Okay, if it's less than, we reject from before. Same rule as before. If it's greater than, we do not reject. So if we reject, we can say there is enough evidence to, in this case, reject the claim because the claim is a null here. Okay, so if you see a problem that asks you to, instead of using rejection regions, use our p-values, you're just going to do this process in the calculator. I chose to do this one together because this one, they didn't give us enough information. There were a few things we had to calculate on our own, like the x. We had to know if it was left tail, right tail, or two tail. Some of the ones that you'll see will be less involved. They might give you the alternative hypothesis, so you'll know what the claim is, that sort of thing. Okay, questions on this problem with the calculator? Yep. You will not need them at all for the test. You will not, just homework. That's it. And then you'll be able to do this for your third project that's coming up. You're going to be doing hypothesis testing, and some of it's going to ask for p-values, so you'll need to use your calculator for that. You need 50 temperatures, 25 men, 25 women by, I think, next Tuesday is when we're going to start doing the project. So you have 8 days notice. Okay. All right. Last question. Oh, that's another one with the calculator. We don't need to do that. Let's go to this question. This is the last one. Create a hypothesis test with proportions about high school seniors. Write a null and alternative hypothesis and label which is the claim. Then determine your level of significance and explain why you chose it. I added this problem into the notes from last year because part of your third project is you will have to create a proportion hypothesis test, and it was the #1 missed thing on the project. So I thought it was worth practicing a little bit. So you can make the claim about anything you want. It needs to be about a proportion. It needs to be a percentage in your claim somewhere. So it can be this percent, more than this percent does something, less than this percent does something, or exactly this percent does something. But the percent needs to be part of your claim. So any suggestions that you want to write? It's the last problem. After we do this, we're done, guys. At least 50% of statistics students do what? Skipped school today. Okay. I like it. All right. So we need to write the null and the alternative. That was our claim. Okay, if it's at least, is it going to be my null or my alternative? At least could be equal to, right? So if it's equal to, it's our null. Remember, the null always has the statement of equality. And at least, would it be less than or equal to or greater than or equal to? Be greater than or equal to 0.50, and that's the claim. Okay, and then the alternative, would that then be less than 50% of statistics students skip school today? Okay. Determine your own level of significance and explain why you picked it. So if I were you, I would pick either 0.01, 0.05, or 0.1 because those are the three values that you have all of the values written in on your Z chart. Remember, the lower your level of significance, the more accurate your results, but the more likely that you might reject something that is actually true. The smaller your level of significance means you are going to essentially have like a smaller confidence interval, I guess. Okay, so think of like 0.10 or 0.15 or 0.2 as like those bigger confidence intervals that we talked about. It's wider, so you're maybe going to get the answer that you want, but you might be going to get one of those type 1 errors too. But when we have a smaller interval, we're narrowing it down so small that sometimes we could reject something that's actually true. So we kind of play a little balance with it. If I were picking one, I would probably pick a level of significance of 0.05. And you could say, because number one, it's on my chart, so I know that value. Okay. Number two, you're going to get pretty valid results with something like that, but you're not very likely to get either a type 1 or a type 2 error. It's not saying that they won't happen, but it's not extremely likely. But when we get those smaller or those bigger percentages, we could reject something that's true or not reject something that isn't true, and that could be bad. Okay. But that's personal preference. There's not like a wrong answer to that. You've seen problems where we use 0.01 and 0.1. It's fine. You just kind of take a risk when you go that route. So, okay, that is it. That is all of 6374. You have no lesson to learn tomorrow. So you guys can use, well, we don't have very much time today. You're going to use all period tomorrow then to work on Math Excel. It's fine. Everybody that's not here can catch up on their own. So your Math Excel is due, remember 7/3 I pushed back until tomorrow night for you. And then 7/4 is due on Thursday night. So those are your only two homework deadlines this week, Tuesday 7/3 and Thursday 7/4. Okay? All right, and tomorrow we got a work day. We did it. All right, I'll do cell phone lotto. Pack it up. And we're done. I'll put these dates on there. Cell phone lotto winner is 7. You know what? I'm gonna push this a few times today. 13, no. 2, no. 8. Oh, 2's there. 2's there. We'll take it. Okay, 2-1.
Oh, wait, really?
Yep.
So, I was not paying attention.
Well, I did hit the button like 4 times today. Just call that a thanks for showing up today. Little win.
Very sad.
Very sad.